Hi guys, welcome back to Calculus with Mr. Robeson. Today we're starting Unit 4. Unit 4 is basically all of the other derivative rules and concepts with derivatives that we haven't had already. So we're throwing them all together here in Unit 4. Today we're going to look at logs and exponentials. This video is just to review all the pre-calc stuff from logs and exponentials. All right, so these are all of our log rules. So, and again, we usually use ln, natural log in this class. But if we're multiplying two things inside the ln, we can write it as adding two separate log expressions. With dividing, it would be subtracting. If we have an exponent on the thing inside the natural log, we can bring that down in front. The natural log of 1 is just 0, because anything to the 0 power gives us 1, including e to the 0 power gives us 1. If we don't have natural log, if we have regular log, we can always switch it to natural log by using the change of base formula. All right, if we have a base, say a, of log of x, then we can change that to the natural log of x over the natural log of a. The natural log of e is 1 because this is log base e. Right, those are all of our log rules. And then we got our exponential rules. So if we have, and then these are really just exponent rules, e to something plus something, we can just say e to the first thing times e to the second thing. We often will do this with a constant, and we can bring this out and call this a constant. If we have something, e to something times x, or two things multiplying, we can pull one of them outside. We could also say this is e to the x raised to the a. That would also work. All right, if we are subtracting in the exponent, we can change it to dividing. All right, e to the ln of something, they cancel each other out, and they just give you what was inside the ln. Same with the reverse order. Really, this x comes down, and ln of e is just 1 from this rule over here. All right, so some examples. So we just want to try and simplify this guy. So we can group this together as these two things to go together and this one, or we can say that these are three separate guys, like this is 1, the x squared is 1, e to the x is 1. We are multiplying in here, so that means we would be adding between the separate logs. So we'd say this is ln of 3 plus the ln of x squared plus the ln of e to the x. All right, now our exponent rules say that we could bring the exponents down. We couldn't do that before because there were multiple things inside here. But now we can. So we get the natural log of 3 plus 2 times the natural log of x plus x times the natural log of e. And the natural log of e is just 1. So we just get x here. All right, this is often easier to simplify first before taking derivatives. All right, later on you'll see that it would be pretty difficult to take this derivative, but taking this derivative is very, very easy. All right, here's something a little more complicated. Same thing, we want to break it up. Here we're dividing, so we're going to be subtracting that guy. So we're going to have ln of x to the third, natural log of x to the third, plus the natural log of the other guy on top, x plus 2 to the fourth, then minus the natural log of what was on the bottom, e to the 3x. We're going to bring all of our exponents down. Right here, we're going to be left with ln of e. That's going to cancel. So we're just going to have 3x from that last term. So we're going to have 3 natural log of x plus 4 natural log of x plus 2 minus 3x. And there's our answer. Simplified, just one term inside each log. All right, we can do the same thing with logs as we were doing with ln's. So this could be the log of 5 plus, and we're multiplying, so we're adding all the things. So we can bring down the 2 on this one. We're going to have 2 log of x. All right, on this one we can bring down the 2x, but log and e are not going to cancel. So we'll have plus 2x times the log of e. Remember, this log is base 10, plus the log of x minus 2. All right. We could have also used change of base there to simplify if we wanted to. With this one, we want to cancel out, but this 3 is in the way. So what we do is we bring the 3 up here as an exponent on the x. So we're kind of going backwards. So it's e to the ln of x to the third. And now these two will cancel out. They've got to be right next to each other. And we just get x to the third. All right, go ahead and stop the video and see if you can simplify this one on your own. I wonder how many of you actually stop the video and do this. All right, so I would say, okay, we're multiplying on top, so we're going to multiply all those. We're dividing by the bottom, so we're going to subtract that one. So this is going to be the natural log of 7 plus the natural log of x to the third plus the natural log of y minus the natural log of e to the fifth. The 3 can come out front. The 5 can come out front. The natural log of e is going to cancel. And the answer that we're going to get looks like it's going to be minus 5. So it looks like it's going to be option B. There it is. Yep. All right. And simplifying with ease. So again, if you want to try this on your own, go ahead and stop it. All right. I'm going to take this guy and bring it up here as an exponent. And I'm going to take this guy and bring it up here as an exponent. So we'll have e to the ln of x squared plus ln of y to the third. Now we kind of want to cancel, but we've got this plus sign here. So what we're going to do is we're going to use exponential rules and say this is e to the ln of x squared times e to the ln of y to the third. Now we can cancel out some stuff. We'll be left with x squared times y to the third, not plus, times. And there it is right there, option C. There's our answer. All right, we can also solve with logs. All right, if we have exponents in, or sorry, if we have variables in the exponents, that's really why we started using logs in the first place, to solve equations that had exponents in the or variables in the exponent. I keep saying it backwards. All right, but to do this, we take the natural log of both sides. Natural log of 7 equals the natural log of e to the x plus 1. And the reason we did that is because exponents now come down. So we get the natural log of 7 equals x plus 1 times ln of e, which is just 1. And now we're just subtracting 1 from each side. So we get the natural log of 7 minus 1. That minus 1 is outside of the log, equals x. And we can just type that into the calculator from here. All right, over here now, if we have natural log, all right, well, one way to cancel out natural log is to take the e of both sides, or make each side the exponent. Like e to this will have to equal e to that if these two things are equal. And now those are going to cancel out. And we're left with 2x minus 3 equals e to the fifth. Now, this is just a number. Now we just got a two-step equation. So we add 3. So 2x equals e to the fifth plus 3. And then divide both sides by 2. All right, so x equals e to the fifth plus 3 divided by 2. And that's perfectly fine to leave your answer just like that on the AP exam. You don't have to throw it in the calculator. All right, so here's another example you want to solve. So again, the first thing we need to do is get e by itself. So we need to get rid of the 2 here. There we go. 2's gone. All right, so we get e to the 3x plus 2 equals 8. All right, now we got to cancel out this e here. We got to bring the exponent down, so we take the natural log of both sides. All right, so these cancel. The exponent comes down. We get 3x plus 2 equals the natural log of 8. So now we're going to subtract 2 from each side and then divide by 3. So we get x equals the natural log of 8 minus 2 all over 3. All right, I'm looking at it for my answer here. I don't see that anywhere. All right, but I do see, we see some 2/3. So it looks like they split it up and put each part over 3. Is that an answer? Not quite. I mean, we got a 2/3 here. This is 8/3. That's not the same thing. All right, but what we can do is we can say that this over 3 is the same thing as 1/3 times the natural log of 8 minus 2/3. And now we can bring this 1/3 in as an exponent on the 8. And 8 to the 1/3 is the same thing as the cube root of 8 minus 2/3. And the cube root of 8 is just 2. There's our answer. All right, so this is just practicing some simplifying rules. So there's lots of things you can do to simplify when you're working with logs and you have numbers either out in front of the log or dividing the whole log. You can always come in as exponents. All right, and just a quick review of the graphs. So remember, this is over here, this is the natural log graph. It has a vertical asymptote at y equals 0. It does not have any horizontal asymptotes. It does keep going up forever. So it's always increasing here. It's increasing on its whole domain. So this is increasing from 0 to infinity. All right, and this was the natural log of x. All right, this is e to the x over here. This is y equals e to the x. It is also increasing everywhere. So it's increasing from negative infinity to infinity, right? It has a horizontal asymptote as we go to negative infinity. We have y equals 0 as an HA. as x goes to negative infinity. All right, on this side, we do just keep increasing. We don't have any vertical asymptotes. We do have this point here. We have an intercept at 0, 1. This guy has an intercept at 1, 0. All right, they are symmetric to each other. If we just reflected over the axis y equals x, one would equal the other. That's a thing about inverse functions. So the domain of each is from 0 to infinity for natural log. We can't plug in 0 in the natural log. We can't take natural log of negative numbers in this class. Yeah, complex analysis you can. All right, and same with e. We can plug in anything we want. All right, so anything, though, so its domain is everything. All right, so that was a quick review of logs. Hopefully that was review. We will use a lot of those properties going forward.